Everybody, it's Jane from Norman S. Wright. The last couple of videos have been about boilers, and I've made a couple statements I want to clarify. 2 videos ago, I talked about how higher efficiencies could be achieved with lower water temperatures, and the last video I said that all boilers were condensing boilers at lower temperatures. So I want to clarify those statements and talk about them a little bit more. So let's get started. So let's start by bringing those 2 statements up here. In the video a couple weeks ago, I said that higher boiler efficiency can be achieved with a lower water temperature. And then the last video, I said that all boilers are condensing boilers if the return water temperature is low enough. So I want to look at this a little bit more because I feel like I didn't quite clarify it. So let's bring back the boiler from the last video. And I've been drawing the boilers and labeling it as cold water in and hot water out. The cold water in is also called the return water, and it is returning from the rest of the system where the hot water was used, and it's returning to the boiler to be heated up again. Let me scoot this over a little bit. Now I want to pull up this graph because I think this graph makes the condensing, non-condensing aspect of the second statement very easy to see. Now looking at this graph, you can see that condensing and non-condensing are really just opposite ends of this same graph. So you can see on this graph that as you get below a certain temperature, it's drawn in around 140 degrees here, you start condensing and your efficiency increases. This graph also shows you a min input and a max input, and this is the firing range of the boiler. The firing range of the boiler is the range of firing rates where the boiler can operate effectively and efficiently. So the min input would be the lowest fuel rate, and the max input is going to be the highest fuel rate. You might also see this written as a turn-down ratio, where a turn-down ratio of 5:1 means you can turn down to a minimum of 20%. You can see throughout the non-condensing range, the efficiency stays somewhere around 88%. But you can see that throughout the firing range, the efficiency increases as the return temperature goes down. In the condensing range, the efficiency is between 94 and 98% efficient. So why does our efficiency go up? As the return temperature gets below the dew point, condensation happens. Condensation unlocks the energy in latent heat. When condensate forms, it releases energy, and it releases up to 8340 BTU per gallon of condensate, which can be up to 12% of the original energy cost. So I wanted to show that graph and kind of tie together my 2 statements about condensing boilers and efficiency. So I hope that makes it a little more clear. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.